Calculate the standard cell potentials of galvanic cell in which the following reactions take place. First is chromium cadmium cell and second one is iron silver cell. Calculate the delta G, the standard value of delta G and equilibrium constant of the reactions. First reaction is chromium changing to chromium 3 plus ion. Now in this equation, the moles of chromium is 2 moles. So chromium changing to chromium 3 plus ion and giving 3 electrons. Now when this whole equation is multiplied by 2, the equation becomes 2 moles of chromium forming 2 moles of chromium ion plus 6 electrons. So total electrons involved is 6. And cadmium 2 plus changing to cadmium 2 plus 2 electron changing to cadmium. To make the number of electrons lost and gained equal, this will be multiplied by 3. So this becomes 3 moles of cadmium plus 6 moles of electron forming 3 moles of cadmium. Now this is the oxidation half reaction, this is the reduction half reaction. Adding these two reactions, number of electrons on the opposite sides will get cancelled and this is the final reaction which is obtained. So the moles of electrons involved in this redox reaction is N is equal to 6. Now reduction potential of chromium is minus 0.74 and reduction potential of cadmium is minus 0.40. So E naught cell is equal to E cathode minus E naught anode, E naught cathode minus E naught anode. So here the one with higher value of reduction potential will act as cathode. So here cadmium has the higher value of reduction potential, so it is acting as the cathode. It is undergoing reduction, so it is acting as the cathode. And chromium is undergoing oxidation, so it is acting as the anode. So minus 0.40 minus 0.74. This is equal to minus 0.40 plus 0.74, which will be equal to 0.34 volt. This is E naught cell. Now delta G naught value for this cell will be delta G naught is equal to minus NFE. Minus NFE naught. So putting the value, what is the value of N? 6. So minus 6 into 96500 multiplied by 0.34. This is equal to 196,860 minus 196,860 joules per mole. Or if it is changed to kilojoules, just divide this value by 1000. So this becomes minus 196.86 kilojoule per mole. Next, the value of K for this reaction, value of K equilibrium constant will be delta G naught is also equal to minus 2.303 RT log K. So delta G value is minus 196,860, R will be 8.314 and temperature is 298 Kelvin. Putting the values and solving, log K is equal to 34.50. So K will be equal to anti-log 34.50, which is equal to 3.16 into 10 to the power 34. Now this is the second part. Now in this cell, iron is undergoing oxidation and silver is undergoing reduction. Silver is undergoing reduction and iron is undergoing oxidation. Reduction potential of iron is 0.77. Reduction potential of silver is 0.80. Now the number of electrons involved in this redox reaction is, when Fe2 plus is changing into Fe3 plus, it is losing 1 electron, and when Ag plus is changing to Ag, it is gaining 1 electron. Adding these two reactions, this redox reaction is obtained. So number of electrons involved in this reaction is 1. Now E naught cell will be equal to E cathode minus E naught anode. E naught cathode minus E naught anode. Now for cathode, which one is cathode? At the cathode, reduction takes place. So cathode is silver, so 0.80 minus anode is iron, 0.77. This will be equal to 0.03 volt. Now delta G naught will be equal to minus NFE naught, minus NFE naught. So value of N is 1, so minus 1 into 96500 coulomb multiplied by 0.03, and this is equal to 2895 joules per mole, and in kilojoules this will be 2.895 minus 2895 joule per mole, and in kilojoules minus 2.895 kilojoule per mole. See, when joule is changed into kilojoule, you have to divide the value by 1000. So 2895 joule, when it is divided by 1000, to change it into kilojoules, it will be minus 2895 divided by 1000 kilojoule. So this is the delta G value. Now delta G naught is also equal to minus 2.303 RT log K. Now value of delta G is minus 2895 joules. R is equal to 8.314. Delta G is equal to minus 2895 joule per mole. R is equal to 8.314. Temperature is equal to 298 Kelvin. Putting the values, log K is equal to 0.5073 and anti-log 0.5073 will give the value of K, which is equal to anti-log 0.5073, and this is equal to 3.2. अब ये डेल्टा जी की यूनिट कैसे आई, जूल्स पर मोल या किलो जूल पर मोल? तो यहाँ पे सबसे पहले पावर होता है, पावर इज इक्वल टू V इंटू आई, वोल्टेज इंटू करेंट. तो वोल्टेज हो गया P अपॉन आई, पावर की यूनिट होती है वॉट एंड करंट की होती है एम्पियर. अब ये जो वॉट है, दिस वॉट इज एक्चुअली जूल पर सेकेंड एंड एम्पियर इज कूलम पर सेकेंड. तो पर सेकेंड कैंसिल हो गया, तो यहाँ पे वोल्टेज की यूनिट आ जाएगी जूल पर कूलम. तो डेल्टा जी नॉट इज इक्वल टू माइनस एन इंटू एफ इंटू ई नॉट. तो यहाँ पे एफ जो है फैराडे, फैराडे की यूनिट क्या होती है, यहाँ फैराडे की यूनिट आ जाएगी कूलम पर मोल और ई नॉट की यूनिट आ जाएगी, ये वोल्टेज है, सो दिस कैन बी रिटन एज जूल पर कूलम. पर कूलम एंड कूलम कैंसिल हो जाएगा और जो डेल्टा जी की यूनिट होगी वो हो जाएगी जूल पर मोल. और इस वाली इक्वेशन में डेल्टा जी इज इक्वल टू माइनस 2.303 RT log K. तो यहाँ पे जो डेल्टा जी की यूनिट आ जाएगी वो हो जाएगी, R की यूनिट है जूल पर केल्विन पर मोल, तो टेम्परेचर की यूनिट है केल्विन. केल्विन एंड पर केल्विन कैंसिल हो जाएगा और डेल्टा जी की यूनिट आ जाएगी जूल पर मोल. और इस जूल्स को जब किलो जूल में कन्वर्ट कर देंगे तो यूनिट हो जाएगी किलो जूल पर मोल.